Morning students, I hope you are ready for your preparation of your mathematics. Make sure you know your laws, rules, formula. Let's go through the slideshow and then afterwards I will go through some examples and important work for the papers. There you see my phone number, so you can phone me or send an email or contact me by WhatsApp. So welcome to mathematics, and I hope you are all working hard to achieve your goals. You are dedicated and self-disciplined. This presentation covers some general guidelines in the subject content. Please keep this in mind when preparing for the examinations. You can all get an A+, why not? So it's algebra, numbers, equations, functions, finance, geometry, trigonometry, probability, statistics that you have to prepare. The numbers, there you see the natural numbers, whole numbers, integers, rational numbers, irrational numbers. So you can go through all the examples that we have there. You can all read this. So I'm not going to read everything for algebra. Then for complex expressions with exponents, if you have to simplify, this one you have to multiply. So there's your first step as well as your second step. If you look at example 2, you have to simplify, and this is also multiplication. How we get to the answer in the end. So if you have a problem there, you can contact me. Factorization. If you have to factorize 3x to the power 3 plus 81, you have to take out the common factor. That's your first step. 3 is a common factor. So then for the formula x is equal to x and y is equal to 3, and then you substitute in the formula. Right, if you work it back, you will get the same answer as we had in the beginning. If you have patterns and rules for numbers and patterns, there are a sequence, for example 3, 5, 7, 9. Each number in the list is called a term, which is T, and T1 is the first term and Tn is any term. Sequences can be described in words. For example, start with 3 and add 2 to get the next term. A rule or function defines the relationship between terms for any term in the sequence. For example, 3, 5, 7, 9 follows the rule Tn is equal to 2n plus 1, where any number can be substituted for n to find the value of the nth term. There's an example. Find the next term in this pattern. So we take 8 minus 2, and 14 minus 8, the previous term, and 20 minus 14. Then we see we have 6 as the common factor. So the next term in the pattern will be 20 plus 6, so it will be 26. Okay, and then you can work through the next example as well. Equations and inequalities, simultaneous equations. Note that you can also draw these graphs. For example, if you have y is equal to 2x minus 4, you can draw the graph. And you can draw the graph of x minus 2y plus 1 if you have it in the form y is equal to mx plus c, which is a straight line graph. So you can draw these graphs and you will get the same answer, where x is 3 and y is 2. So if you draw the two graphs, your point where the two lines will meet will be where x is 3 and y is 2. Right? The types of algebraic graphs. There you see a linear graph, which is a straight line. The equation is equal to y is equal to ax plus q. Or we all sometimes say y is equal to mx plus c. quadratic, for example, parabola, y is equal to ax squared plus q. There you see the form of the graph. Hyperbolic, the hyperbola, y is equal to, for example, a over x plus q, where x is not equal to 0 and y is not equal to q. There you see the length and the breadth. And for example, y is equal to 20 over x. The graph will look like that one. It will not touch the y axis, and it will also not touch the x-axis. Exponential graph, there you see a graph like that. For example, y is equal to 2 to the power x, where x is time in hours. At the bottom, straight lines, parabolas, and exponential graphs are continuous as there is a y value for every x value. And hyperbolas are not continuous as there are no y values for x is equal to 0. The data sets for hyperbolas are therefore discrete data. Calculations with simple interest, investments, and debts. Typical exam questions will be calculate the amount of interest earned or paid, calculate the total amount earned or paid, calculate the time it takes to earn X amount in interest, calculate the time it takes for an investment to grow to X amount, calculate the rate of interest that was paid or charged. Therefore, change the subject of the formula in order to find the missing value. There are some examples that you can go through for finance. Then geometry and measurement, similarity and congruence of triangles. There you see congruent triangles. The sides are the same, the angles are the same, the corresponding measurements are equal. Congruent triangles may have different orientations. They could be reflections of each other, or one triangle could be rotated through a number of degrees. So A and B are, for the second example, also congruent. So you can go through that as well. And then at the bottom you will see similar triangles have the same shape, but they do not have the same size. Then they are similar. So the x angles are the same size, the y angles are the same size, and the z, but the lengths of the sides are not the same. Then they are similar. Surface area, make sure you know your formula there as well. Volume, there you can have a look at the volume, find the volume of the solid. The area of the base is equal to the area of the square, 4,5 times 4,5, and the height is 9, so the volume will be A times the height, the area times the height. So you can go through that. And then the example for the cylinder, the area of the base is the area of a circle, pi radius square. Then we have the area of the circle, and we times it with the height to find the volume of the cylinder. Trigonometry, we know that sin theta will be the opposite side over the hypotenuse, and cos will be the adjacent side over the hypotenuse, and tan will be the opposite side over the adjacent. And there are some examples that you can go through. Revision of probability terminology. The event of outcome of an experiment, for example, a coin lands with heads facing up. Complementary event and experiment, experimental probability, mutually exclusive events, outcomes, probability, random, sample space, theoretical probability. You can go through the words that you need to know. The revision of the calculating the mean, the median and the mode. You have data. You have a data set. You have the mean. Look carefully how you have to find the mean. The mean is the sum of all values divided by the number of values. So make sure about that. The median is the middle value in a data set when the data are placed in order. And at the bottom, the mode is the value that occurs most often. In other words, it is the value that has the greatest frequency. That's always asked in the exams. How to prepare for the exam? Ensure that you have all the study materials or resources required for the modules. Please ensure that you spend enough time reading the prescribed materials and to follow the instructions carefully so as to ensure that you do not waste unnecessary time and effort. Take time to first acquaint yourself with the content of the module by reading through the material carefully. Make sure you understand the terms used very well. For example, eliminate, substitute, factorize. Always pay attention to the marks allocated to each question and answer accordingly. Never leave any question unanswered, and revise your assignments and ask your tutor if you have any problems. Right, good luck in your exams. I would like to go through some other material as well. So I will go through real numbers. We have natural numbers, there are examples, whole numbers, integers, rational numbers, and then irrational numbers. For example, pi and the root of 2. Then the examples of transformations that map object A onto the images B, C, and D. A onto B will be enlargement. The scale factor is 3. It's 3 times bigger. And the center of enlargement is the point -7, -7. If we look at the next page, you will see how we find the center of enlargement. We draw the lines from the angles, corresponding angles, to A and the other angle. We can also draw lines with a ruler, and then we see the point where they meet is -7 and -7. So that's the center of enlargement. If A is mapped onto C, that means it is rotated. If you look at A and C, you will see it is turned, and it's turned 180 degrees. And the point where they turn, if you can draw your line, you will see it's at 0 for the x value, and for the y value it is -6. If you map A onto D, if you look at them, you will see there's a line there, D, by means of a reflection. So it's reflected there. There's a mirror line, and the line is the y-axis. We know that this is the y-axis, and this is our x-axis. Right, so there are 3 different transformations. Then adding and subtracting expressions. If you add the following expressions, you add all the x squared values. There is an x squared value, another x squared value. So if you add 1x squared to -6x squared, you will get -5x squared. It stays x squared, it doesn't become x squared, x to the power 4. Then you add all the 2x, all the x values, you add -2, -2, and +7. Then we get 3x. Then you add all the numbers, 4 plus 5 minus 9. 4 plus 5 is 9 minus 9, so it's +0, so nothing. If you have to subtract the first bracket from the second one, then we write the second bracket first and then the first bracket. When we multiply in, it's becoming minus 6x squared. Minus times minus is plus 5x, and minus times plus is minus 3. Then we again just add up. 11 minus 6 will be 5, and the x values, minus 9 plus 5, minus 4, and minus 12 minus 3 will be minus 15. And you leave it like that. If you have to factorize completely. So you take out the highest common factor. And the highest common factor will be x squared. So it will become x squared, and then in brackets, the 3 plus y. And close your bracket. Right, the same with the numbers, next numbers there. Then, there's a summary of the graphs of direct and inverse proportions. Direct proportion is a straight line graph, and make sure you always draw your graphs, straight line graphs, with a ruler. And it starts at 0, 0. The inverse proportion graph will be a curved graph called a hyperbola, and you always draw it with a pencil. It must be a smooth curve. The graph never intersects either the axis, so it doesn't go through x or y. When an x value is small, the corresponding y value is large, and the other way around as well. There we see again direct proportion. For example, the straight line graph, y is equal to mx plus c. Plus c is now 0, so it goes through 0. And there you see the inverse proportion. For example, y is equal to 6 over x. Or the same is xy is equal to 6. X times y is equal to 6. Inverse proportion, for example, y is equal to minus 20 over x, or xy is equal to minus 20. Then it will be in these two positions. Here we see the laws of indices and their application. These laws you must know. A to the power n times a to the power n will be a to the power m plus n. And then for a to the power n divided by a to the power n will be a to the power m subtract n. And you have a bracket, a to the power m to the power n, then it becomes a to the power m times n. If you have, for example, number 4, a to the power m as well as b to the power m, both are to the power m, so we can say a times b in brackets to the power m. And there are some examples. There you can use the rules to follow the instructions there. Compound interest. Some words that we use, we went through it on the other slideshow as well. For example, simple interest is calculated with the formula. The interest is the principal times the interest rate times the time in years. And we must remember that a year has 12 months. For example, calculate the interest earned on 2,000 invested for 3 years at 8% per annum. Simple interest. So it's P times rate times T divided by 100. 2,000 is the principal money, and 8 is percentage times 3 years. Remember to divide by 100 because it's 8%. And you use your calculator. Here we see the triangle, quadrilateral, pentagon, hexagon, and the octagon. So with 3 sides, the sum of the interior angles add up to 180 degrees. And here we have an equilateral triangle with all the sides the same, or the 3 sides the same. the three angles the same size, then it's called equilateral. To find one angle, we can just divide by 3. When you have 4 sides, we can divide it into 2 triangles. So the sum of the interior angles will be 180 times 2. If you have a regular polygon with 4 sides, then we have a square. All the sides the same, all the angles are, or the 4 angles are 90 degrees. And then we can take 360 degrees divided by 4, so all the angles are 90 degrees. The pentagon we can divide into 3 triangles, so 180 times 3. If you have a regular pentagon, the sides are the same, the angles are all the same size, so 540 divided by 5. If you have to find the interior angle of a polygon, in a polygon with n sides, we take the sum of the interior angles, n, and subtract 2 times 180. And then when you have a regular polygon with n sides, each interior angle is n minus 2 times 180 divided by n. You can go through the examples as well. We must remember, for circles, the angle in a semicircle is 90 degrees. So if there is a line through the middle of the circle, the angle on the side will be 90 degrees. The angle between a radius and the tangent is 90 degrees, so this angle will be 90 degrees and 90 degrees. And make sure you call the angle APO. We can't just say angle P, because there are 3 angles at P. The tangents to a circle drawn from the same point outside the circle are equal. So AP is equal to BP. And the angle at OAP is 90 degrees, as well as the angle at OVP, also 90 degrees. There are some examples that you can go through. Linear functions and their graphs, and functions equations in general. The area of a circular flower bed is related to the radius of the circle. And remember the formula. The area of a circle is pi radius square. We must always remember that it is always in square meters, for example. So pi radius square, and the answer will be in meters square, or in square millimeters, or square centimeters. The gradient of a straight line. The straight line graph, this is a positive gradient because the graph is going up. Then we take the vertical change and over the horizontal change. So vertical, this one first, so plus 4 over plus 2. Then we have the gradient of this line. If we take the gradient of this line, we take the horizontal at the bottom and the vertical at the top. So vertical minus 2 over minus 3. Then we divide it and we get 2 over 3, which is positive now, because minus and minus can cancel each other. Or minus divided by minus is a positive. So this is a rising graph. This is a falling graph going down. Then we take the vertical, minus 4 over plus 2. Minus 4 over plus 2 will give us minus 2. You can work it out with your calculator if you don't remember this. And here we take again the vertical over the horizontal. So plus 2 over minus 4. Then we have a falling graph, so it will be a negative gradient, minus 1 over 2. Here's an example of the heights of plants represent the continuous data. The measurement depends on the accuracy of the measuring device. The table shows the heights of 50 plants. So if you add up the frequency, it will give you 50. And we started at 10, it's equal to 10, and it goes to just less than 15. And make sure your intervals are always exactly the same. So use your ruler to draw it if you have to draw a graph like this. So make sure 2, 4, 6, 8, and the intervals are the same space. 10, 15, 20, 25, 30, 35. And you draw it with a ruler and a pencil. So there you see the information. Bearings and scale drawings. We always start from north. So the diagram shows the different directions in which 4 learners are walking. Write down the bearing for each one. So we start from north, this is 40, then from north again 145, from north again to 200, and from north again up to Doreen, which is 310. If you have to draw this, you use your I forgot the word now. You have to work with a compass, and you have to draw it with your, not a pair of compasses. But anyway, you start and put it like this. You start from north always. Okay, here again we've done the sin, the cos. To make sure you know how you work it out, you always use your angle that is given and work from there. The volume and the surface area. If you have to find the volume of a cube, you use side times side times side. And make sure your measurements are the same. For example, all of them are in meters or in centimeters. The volume of a cuboid is the length times the breadth times the height. The length times the breadth times the height. The volume of a cylinder is pi radius squared, so it's the area of the circle times the height. So that's how you find the volume. The equation of a straight line, y is equal to mx plus c, where m and c are numbers. We also call it constants. In y is equal to 2x minus 4. M is 2 and c is minus 4. And the same here for the second one. The second one, y is equal to minus x. So in front of the x there's a 1, so it's minus 1. And 2. Where m is minus 1 and c is equal to 2. In y is equal to half x. The m is the gradient. The gradient is a half. And c is the y-intercept, where it goes through the y-axis. So it will go through 0 there, if you have to draw it. Here we have some examples of how to solve x. X squared is 9. So we can take the root of x squared and the root of 9, and then we get x is equal to 3. X is equal to 3, but it could also be equal to minus 3. So the solution is x is 3 or x is equal to minus 3. The same here, x squared is equal to 2x. Here we can take out x as a common factor. And in brackets we have x minus 2 and make it equal to 0. So either x is 0 or the bracket x minus 2 is equal to 0. So x is equal to 0 or x could be equal to 2 if you have to take 2 on the other side. The next one, x squared minus 3x minus 4 is equal to 0. So rearrange it so that you make it equal to 0. Then you factorize. X minus 4 in brackets, x plus 1 will give you 0. So either this bracket or that bracket will be equal to 0. Then you simplify, x is equal to 4 or x is equal to minus 1. And you can check your answer. Here we have a graph again, parabola. You see the form here. Again, your intervals must be exactly the same. Your intervals must be the same on your x-axis as well as your y-axis. So make sure you use your ruler and draw your lines with your ruler. But the parabola you draw with a free hand, it must be a smooth curve. What is the equation of the axis of symmetry? Is the first question. So that will be x is equal to minus 5. X is equal to minus 5. This is the line of symmetry. The minimum value of, write down the minimum value of y, where y is the minimum value, it will be minus 4,25. So this is the lowest point. The coordinates of the turning point, the point where it turns is for the x value minus 1,5, the x value, and the y value is minus 4,25. Right, and then you can also find the coordinates to find y. If x is 4, so go through your graph and where x is 4, what is your y value? Your y value will then be 2. So you read it off your graph. And solve the equation x squared minus 3x plus 2 is equal to 0. So where is it 0? At the 2 points. There are 2 points where it is 0. Where x is 4,2. Solve the equation, number E. It will be the roots. So there you can see the answer. And on your graph, draw the line y is equal to minus 3. Y is equal to minus 3. You draw the line. Y is equal to minus 3. And read off the x-axis as shown. X is 0,4 and 2,6. There's a solution. They ask, solve the equation. There you see it. Where it is minus 3, you can draw the line. X is minus 3 and you find the values there. Right. Let's see the next one. Yeah, we can read off all the answers from the graph. So if you can go through this and just read it off your graph. Here we have mixed examples for circles and triangles. So in the diagram, 0 is the center of the circle. The straight line AC and BD intersect in O, the tangent to the circle at A meets CD, reduced to E. Explain y angle. Oh, we can work here on the graph. We can see that these two angles are the same, those two angles are the same. And the radii of the circle are the same. So that will be the same. And we know that the angle here at CAE will be 90 degrees. We've learned before. So using all the information that you've got, you can work out all the angles of the graph here. So explain why angle CAE is 90 degrees. The angle between a radius and the tangent is equal to 90 degrees. How do we find the reasons of the size of angle ACD? ACD, we can find this angle. We can say this one is 90 degrees, this one is 42. If you look in the triangle, then we can find the angle. Angle ABD. ABD, this angle we can find because we know the other angles that we've got. This angle is 40 degrees because the two angles are the same. This angle and this one will be the same because its angles at the circumference are both subtended by AD. It's subtended by the same line there. Angle AOD. AOD, what's the size of this angle? The angle at the center is double the angle at the circumference. So it will be 2 times angle ABD, so it's 82. 42 times 2, 84. Right. And here are some more examples that we've done already. Right, good luck students. I hope it will go well with you in the exams. If you have any problems, you can ask me and you can email or you can WhatsApp anytime. Good luck.